Good afternoon, dear students. Today we are going to see about the basic concepts of chemistry. In that, chemical calculation, that is a lesson in 11th chemistry, first lesson that we are going to discuss now. Okay. See, the chemistry in everywhere. Everything made up of matters. Matter, all matter made up of atoms. If you know, in Tamil there is sayings goes on like this. Unna udavu, udukka udai, irukka idam. Likewise, to food we eat, okay, cloth we dress. Likewise, everything is made up of chemistry. In all those things, you have a chemistry behind that. Where whatever food you are eating, what the medicine you are taking, what the dresses you are wearing, and industrial purposes you are earning, all those areas the chemistry is applied. Okay, so we should know how the chemistry linked together in our day-to-day life. Without chemistry, even a single minute cannot move without chemistry. That is the thing. So everything is made up of matter. Matter is made up of atom. How? What is called matter? That is what is called matter? Let us define the matter. What is the matter? Matter is nothing but which has the mass and occupy the space. Which has a definite mass and occupy the space. That is called matter. Matter can be defined as that which has the mass and occupy the space. That is called matter. That is called matter. Matter can be further classified into many types. Based on the physical classification, matter can be based on the physical classification. Physical classification, that is, as you know very well, that is solid, liquid and gas. Solid, liquid and gas. Okay. See, even a single compound is a different form. For example, if you take water, ice is a solid. Ice is a solid. The water liquid. The same way, vapor is a gaseous form. So, in a physical classification, matter can be classified into solid, liquid, gas. Okay. Then let us move on to the chemical classification. Now let us see the chemical classification. How the matter classified into chemical method. Chemical classification, that is a mixture and pure substance. Mixture and a pure substance. Mixture further classified into homogeneous mixture and heterogeneous mixture. Homogeneous mixture and heterogeneous mixture. Okay. A pure substance further classified into two types, that is a compound and element. Okay. So this is the way how matter is classified into chemical method. Okay. Then matter is the substance which occupy the space and having the mass, that is called matter. Okay. Then it is chemically it's classified into mixture and pure substance. In mixture, you have homogeneous mixture and heterogeneous mixture. What is called a mixture, sir? Mixture is a combination of more element. Okay. Mixture is a combination of more element without chemical interaction. That is called a mixture. That is homogeneous mixture. For example, tea. Tea is a homogeneous mixture. Okay, because tea contains many particles. What are the particles? Milk is there, tea powder is there, water is there, additional to sugar is there. All are mixed together, but there is no chemical contact with this. There is homogeneous within the one form. If you see tea, simply if you see tea only, you can visible. This is a homogeneous mixture. Then a heterogeneous mixture. Water in oil. If you pour oil in water, you can see the difference between the two substances. If the oil layer will be there above the water, the layer of oil you can see, that is called heterogeneous. There more than different substance mixed together without chemical interaction, visibility is there. Okay, they also heterogeneous only. But oil in water, you can see that difference. The substance in a you can visible because in the water the oil layer will be up. That is called a heterogeneous mixture. Then a pure substance. Pure substance, it may be a single substance or a combination of same elements. That is called a pure substance. Okay, pure substance can be classified into element and a compound. Elements are made up of same type of atoms. Elements are made up of same type of atom. Okay, number of atoms combined together, that is form an element. Whereas, for example, copper is an element. Copper is an element. When a compound, copper sulfate. Copper sulfate. For example, copper sulfate we can give as a compound. Here copper is there, sulfur is there, oxygen is there. So combined to form a copper sulfate. Copper sulfate is a compound, whereas the element is a copper. Okay. This is way how chemically matters are classified. Already we have seen the physical classification. Then we have seen that chemical classification. Let us move on to the atomic mass. Atomic mass. Atomic masses. So as we know very well, atom is very small tiny particle. For example, the diameter of the atom will be 10 power minus 10 meter. That is diameter of the atom. Then weight about 10 power minus 27 kilogram. See, 10 power minus 10, 10 power minus 27. Imagine that how much small is it. This can be we cannot weigh easily this one. So we are in the position to have a relative masses. So atomic masses, it is simply very tiny particle. So comparatively we are having the relative atomic masses. For this, the standard unit IUPAC is giving the standard scale to measure the atomic masses. For example, 1 by 12th of carbon 12. Carbon 12 is isotope. Carbon 12. Okay. You have isotope, a different isotope. What is called isotope? Isotope having same atomic number, different mass number. Carbon 11 is there, carbon 12, carbon 13, carbon 14, carbon. Likewise, it is go on isotopes. Here, in a carbon 12 isotope, 1 by 12th part of the carbon 12 isotope, that is called a unified mass. This is called a unified mass. This is taken by IUPAC standard as a standard measurement. This is a unified mass. This value around the unified mass value around 1.6650 into 10 power minus 27 gram. Okay, 27 kilogram. This is a unified atomic mass. Unified atomic mass. So, come to the relative atomic mass. Relative atomic mass. That is equal to average mass of atom. Average mass of atom divided by unified atomic mass. So average mass of atom divided by unified atomic mass. Okay. If you know average atomic mass, then divided by that unified atomic mass. If you are getting that, you are getting that relative atomic mass. So for relative atomic mass, there will not be any unit there. Okay. See. Then what is the unit of atomic mass? Atomic mass AMU. Atomic mass unit will be given. Atomic mass unit. AMU. Atomic mass unit. Then if it is weighed in a gram, then you can gram atomic mass. If atomic mass is weighed in a gram, that is called a gram atomic mass. This is a question may be asked. What is the unit of relative atomic mass? If they ask relative atomic mass, that is the relative factor. It will not have a unit at all. Everything will be cancelled. So relative atomic mass, there will be no unit. But what is the atomic mass? Unit of atomic mass, if they give that is a AMU, atomic mass unit you can give. Simply they will give a U. Okay. If they ask, the question is what is the gram atomic mass if they given that is unit will be gram. So the difference you should know. Relative atomic mass, no unit. Atomic mass if they ask, that is AMU. If the question is like this, gram atomic mass if they ask, you should give a gram. Okay. Atomic mass weight in a gram, there is gram atomic mass. Relative atomic mass, no unit at all. Okay. Now it's clear. In this way, you have atomic masses of different elements, their different values are there. Okay. So simply we can say there is a ratio between the average mass of atom divided by the unified atomic mass. Okay. Or the mass of the atom to the 1/12 of carbon 12. Okay. This anything can be given as a definition for atomic mass. Then let us move on to the molecular mass. Molecular masses. Molecular masses. Okay. What is molecule? A combination of atoms called a molecule. Okay. More than one atom mixed together, that is given a molecule. For example, hydrogen atom H, hydrogen molecule H2, oxygen atom O, oxygen molecule O2. Okay. Like this it goes on. The same way, molecular mass also can be calculated. Here, what is the ratio between the molecular mass that is equal to ratio between the average mass of the molecule. There we have seen atom, here in the molecule divided by the unified atomic mass. Unified atomic mass. For example, you want a molecular mass of hydrogen. Okay, H2 hydrogen molecule. So what is the atomic mass of hydrogen? Atomic mass of hydrogen, that is equal to 1.008. Then what is the molecular mass? This is a atomic mass of the hydrogen. Atomic mass. Atomic mass of hydrogen atom. Okay. Then molecular mass, how many? So it is simple, but simple thing. Atomic mass into atomicity we can say how many atoms are present in a hydrogen molecule? 2. So molecular mass of hydrogen. Molecular mass of hydrogen, that is H2, that is equal to 2 into 1.008. So this is where we will give you a molecular mass. Okay. Before that, we need to say the relative atomic mass and the relative molecular mass, that is left. Before that, molecular mass you should know. Why the concept is coming here? The relative atomic mass, because each and every element they are existing in the more than one isotopes. Okay, number of isotopes are available. Okay, so we cannot decide easily if there is no isotope at all for element. We can say this is fixed. If there is isotope, for example, if you take chlorine, Cl35 is there, Cl37 is there. Both of them are there. Okay, so how to calculate the atomic mass of the chlorine? Because we cannot say it always will be existing in this. If you take chlorine always, you cannot say that chlorine 35 will be there or chlorine 37 will be there. They are mixed together, abundant in the natural existence. They are mixed together. For example, it may be 77%. For assuming that 77% of chlorine 35, 23% of chlorine 37 is there, then how to calculate the atomic mass of this case? Here, if you take 77%, 35 into 77% plus 37 into 23% divided by 100. This is relative atomic mass. You can calculate by using this isotopes. If closely come around 35.45. That's why we are assuming that what is the atomic mass of chlorine? Chlorine 35.5. We are giving the data. This is how it comes in natural existing chlorine 35 and 37 are there. They mixed form 77% and 23% 37 is there. So this value get together, finally you are getting that molecular atomic mass of chlorine will be 35.45, at closely we can say 35.5. Okay. Now we are going to discuss some molecular mass of some compound we are going to calculate now. Okay. Let us calculate the molecular mass of ethyl alcohol C2H5OH and then KMnO4 and then K2Cr27 and then suppose C2 okay. Now we are going to calculate the molecular mass of this species. For example, ethyl alcohol, first of all, molecular mass can be given easily, that is the sum of the atomic masses. Sum of the atomic masses, it will give you molecular mass. So, I am taking how to calculate the C2H5OH ethyl alcohol. The data you should memorize for preliminary data. For carbon, what is the atomic mass of carbon? What is the atomic mass of hydrogen? What is the atomic mass of oxygen? That should you know. In lower classes they may given in a bracket, in higher classes they will not give. You will have a table in your book that you need to memorize, then only it will be very easy. For example, carbon is 12, so 12 into 2 plus hydrogen 1 into 5 plus oxygen 16 into 1. Hydrogen already, so totally 6 hydrogens are there, so 6 here. Then it will be 24 plus 6 plus 16. So net value how much? 40, 30, 46. 46. If we get a gram, 46 gram, 46, which unit you need. Likewise, KMnO4. KMnO4. Okay. Then K2, Cr2, O7. Then potassium 39, manganese 55, oxygen 16. That is you know very well. Just atomic number you should know. Here also 39. Chromium 52, oxygen 16, no problem. And carbon dissolution number 12, 1, 16. So these are the atomic masses. Now we are going to calculate. How many potassium are there? Only one, so 39. Plus, how many manganese? 50, only one, so 55. Then oxygen 16, is 4 times. Okay, if you sum up the value, you can get the answer. Okay, likewise, here, potassium, here 2 potassiums are there, so 39 into 2. Okay, potassium 39 into 2 plus K2Cr2, 52. There are 2 chromium atoms are there. For one atom, 52. So 52 into 2, then plus oxygen 16. Atomic mass of oxygen 16, there are 7 oxygens are there. So you sum up the value, you can find the answer. Likewise, sucrose, how many carbons are there? Carbon atomic number 12. So 12 into 12. Okay, 12 into 12. Then plus, how many hydrogens are there? Hydrogen 1 into 22. Atomic mass of hydrogen 1. That is 22 hydrogens are there. Plus atomic mass of oxygen 16 is 11. So if you do all the sum of the, you can find the answer. This is a way how you are getting that atomic mass and molecular masses. Okay, thank you.